OpenArc recently worked on a project with the University of Pittsburgh. This project was a wearable circadian rhythm monitoring system used by consumers in medical settings.
That sounds really interesting, Mark, but can you tell us what is a circadian rhythm?
A circadian rhythm is our natural internal process that regulates our sleep-wake cycle every 24 hours.
That sounds cool, but why is that important?
Circadian rhythm problems are a leading contributor to certain health conditions such as dementia, depression, and diabetes.
So you talked a little bit about what circadian rhythm is. Can you tell us an overview of the functionality?
Sure. On the user's watch, we were responsible for gathering accelerometer data and pushing that up to our back-end server so that it could perform complex algorithms. And on the phone, we would display their daily activity levels and also their CAP score.
So there's quite a bit of functionality there. It sounds like it's fairly complex. Can you talk a little bit about the architecture?
Sure, we'll start with our back-end solution. We ended up using Amazon Web Services, and in AWS, we leveraged the following services. Cognito for our user management, S3 for our block storage. We used RDS for our database system. Lambda functions. Inside of Lambda, we used the Java programming language, and that was responsible for performing all of our complex algorithms.
So that explained the back end at a high level. Can you talk some about the watch and the phone?
On the phone side of things, in the watch, we needed a way to communicate between one another. So we need to be able to send messages between the watch and the phone and vice versa. So luckily, Apple gives us something called a WC session that allows us to send data, files, and other types of messages between the two devices. On the watch side, we needed an intelligent way of gathering historical accelerometer data. And the CM sensor recorder does give us that data, but it is very limited. On the phone, we used Amazon Cognito, as I mentioned previously, for our user management, for logging in and registering. We used ResearchKit from Apple to help us with our onboarding process. And also, ResearchKit gives us a bunch of charts and graphs so that we can display users' daily activities to the user.
So there's a lot going on there. Any chance you ran into some limitations?
We sure did. Given the Apple Watch and the size of the Apple Watch, as a developer, we really had to pay attention to the memory usage and also the processing power that we were using. The background execution time is very limited on the watch, as a lot of our data has to be done on the background thread. Also, battery and charging. Low power mode, we ran into some difficulties retrieving historical data, and also while sitting on the charger. On the phone side of things, not so much. Given that the iPhone has been out there for many years and we have a lot of memory and the CPU is pretty good, the only thing we really had to worry about was the background execution time.
So it sounds like it could be pretty challenging dealing with an app that has to use both the watch and the phone.
Right.
So what are some of the things that you did to overcome those limitations?
The first thing we did was we removed the watch from the scenario completely. We started with the phone and AWS. We had to prove to our client that we were able to retrieve historical accelerometer data and upload it and perform the complex algorithms on the server. We also worked with Apple throughout the project. Our contact at Apple, we would float ideas back and forth, come up with various prototypes, and at the end, we were able to come up with a viable solution for our customer. Given all the technical challenges that we had with this project, this was a lot of fun from a developer perspective. It was very challenging and rewarding whenever we were able to get a viable solution to our customer. I hope that you find this information useful.